The basics of flight: lift, thrust, and gravity. Planes stay airborne due to the balance of four key forces: lift, weight, gravity, thrust, and drag. Lift is the force that counteracts gravity, allowing the plane to rise off the ground. Thrust propels the plane forward, while drag works against its motion. The proper balance of these forces keeps the plane flying smoothly in the air. How lift is generated by wings. The wings of an airplane are designed to generate lift. The shape of the wing, called an airfoil, causes air to move faster over the top of the wing and slower underneath. According to Bernoulli's principle, this difference in speed creates a pressure difference, with lower pressure above the wing and higher pressure below it, which lifts the plane into the air. Thrust. The engine's role in propulsion. Thrust is the force that moves the plane forward, and it is generated by the engines. Whether jet engines or propellers, the engines push air backwards, which in turn propels the plane forward. As the plane moves forward, air flows over the wings, allowing lift to be generated. Without thrust, the plane would not move fast enough to maintain lift. Gravity. The force of weight. Gravity pulls everything towards the Earth, and the plane's weight works against the lift generated by the wings. In order for a plane to stay airborne, the lift must be greater than or equal to the force of gravity. This balance is maintained as long as the plane continues moving forward at the right speed to generate enough lift. Drag. Air resistance against the plane. Drag is the resistance that air exerts on the plane as it moves forward. This force works against thrust, slowing the plane down. To stay airborne and maintain speed, planes must have engines powerful enough to overcome drag. Streamlined shapes and aerodynamic designs help reduce drag, allowing planes to fly efficiently and at higher speeds. The importance of speed in flight. Planes need to reach a certain speed to generate enough lift for takeoff. As the plane accelerates on the runway, air flows faster over the wings, increasing lift. Once the plane reaches the required speed, it can take off, as the lift exceeds the force of gravity. Maintaining this speed is essential to keep the plane airborne. How airplanes turn and change altitude. Planes can change altitude and direction through adjustments in thrust, lift, and the control surfaces of the wings and tail. To turn, a pilot uses the ailerons and rudder to change the plane's roll and yaw. To climb, the pilot increases thrust or adjusts the angle of attack to generate more lift, while to descend, the pilot reduces thrust or adjusts the plane's angle to reduce lift. Stability and control in flight. Airplanes are designed with stability in mind. The wings are typically located near the middle of the fuselage, providing balance. The tail, which includes the horizontal stabilizer and vertical fin, helps control the pitch and yaw of the plane. Together, these features help keep the plane stable and prevent unwanted movements during flight. The role of air density in lift. Air density affects how much lift the wings can generate. At higher altitudes, the air is less dense, so planes need to fly faster to generate enough lift. This is why planes must accelerate to higher speeds at takeoff and climb to maintain altitude. Weather conditions, such as temperature and humidity, can also affect air density and flight dynamics. Understanding the physics of flight. In essence, planes stay airborne because they are designed to balance and control the forces acting on them. Through careful engineering, planes use aerodynamics to generate lift, thrust to propel forward, and control mechanisms to manage altitude and direction. This combination allows them to safely and efficiently stay in the air for long distances.